Hey everybody, welcome to finding the inverse of a function. This is Nicholas JMV. So today we're going to be finding the inverse of functions, and so the procedure that we're going to follow is we're going to replace our function. It doesn't have to be f of x, could be g of x, h of x, t of x, r of x. Just replace your function notation with y. Next you're going to switch your x and y's around. You're going to resolve that equation for y, so essentially you're just going to solve for y, and then you're going to replace y with the inverse notation. Now, in order for a function to have an inverse, it's got to be 1-to-1. Or in other words, it has to pass the horizontal line test. Now, each of these examples pass the horizontal line test. For example, part A, that's a linear function, okay? So we're going to be finding the inverse of each function if it exists. They all pass the horizontal line test. So let's go ahead and find these inverses. So step number 1 says to replace f of x with y. So we're going to have y, and that's going to equal, we're just going to leave everything else the same, equals 3x minus 6. The second step tells us to now switch the x and the y. So x goes where y is, and then if I drop that down, y, sorry, I kind of like to keep the same color, equals 3y minus 6, right? So we just switch x and y. Now you resolve that equation for y. So I'm going to add 6 to both sides. Okay, I have x plus 6 equals 3y. Divide each side by 3. So there I've resolved the equation for y. Okay, and now I replace y with, in this case it was a function f inverse, so it's going to be f, we're going to show the inverse symbol, and that equals x plus 6 over 3. So there's your procedure to find the inverse of a function. Okay, so let's look at example 2. Our example 2, it's a square root function, and it's g of x. So g of x is going to get replaced with y, so we're going to say y equals the square root of x plus 2. Then we re-switch x, and we're going to switch x and y, so x switches with y. Okay, and now you have to resolve that equation for y, but y is under the square root, so I'm going to go ahead and square both sides. So I'm left with x squared equals y plus 2, and I go ahead and subtract 2 from both sides. And I got y by itself, and now we switch out the y with, in this case our function was g of x, so it's g inverse of x. You do not want to put the wrong name down, so then we have x squared minus 2. So that is the inverse of g of x. Our last example, h of x equals x plus 2 over x. So again, you're going to replace h of x. Let's replace h of x with y. So you're going to write y equals x plus 2 over x. Now we switch x and y around. Okay, so we have x equals, now we got to be really careful here. We're going to have y in the top and y in the bottom. Okay, so it's going to be y plus 2 over y. So notice how wherever there's an x, I replace it with y. So it's two y's there. It's not just one time. So all the x's replaced with y, and same, all the y's are replaced with x. You're going to go ahead and cross multiply here. So I'm going to have x times y equals y plus 2. Okay, now I've got two terms with y, so I'm going to go ahead and bring one of them over. I'm going to bring the y term over. So I have x y minus y equals 2. And notice how both terms have a y in common. So I'm going to factor out the y, and I'm left with x minus 1 equals 2. And now I'll divide each side by x minus 1. So I have y equals 2 over x minus 1. And now we replace y with our inverse. So it was h, so it's h inverse of x. And that's going to equal 2 over x minus 1. Obviously, we do not want x cannot equal 1 there. Okay, there's that inverse. So those are 3 examples of how to find inverses of functions algebraically. Again, if they exist, you need to pass the horizontal line test. So if you have any questions or comments, let me know. We'll see you next time.